Alright, you guys, we are looking at another circuit again, and now in this circuit it's divided into two parts. We have the smaller circuit, a simpler circuit, and we also have a more complex circuit here, and what is linking them is a relay. So we want to look at the special component that is called a relay in this video. Alright, so now if you should define a relay is an electromagnetic switch that uses a small electric signal to control a much larger circuit. So this is a smaller signal where it's coming from the 5-volt battery. Now you want to control a much larger circuit. This is a much larger circuit, as of course we can see that it's divided into two parts. We have a part where we have the lamp, and the second part is where we have the resistor and we have the red LED. Alright, now how does this relay work? The relay has 5 pins, as you can see. These are pin 1, pin 2, pin 3, pin 4, and pin 5. Now this first 2 pins is where the input comes from, the input signal, the input electric signal comes from. Now in that input electric signal, the voltage must match the relay voltage. So we are using a voltage of 5. That tells us that our relay voltage must be 5 volts. There are different types of relay. We have a 5-volt relay, we have a 12-volt relay, and we also have a 24-volt relay. Alright, now the hierarchy of the relay occurs in 3 ways. We have the electrical input, which comes from the smaller circuit. The electrical input comes from the smaller circuits. We have the magnetic action, which occurs in the coil. The magnetic action occurs in the coil, and we have the mechanical switching, which occurs between the last 3 pins. Now I'm going to identify the last 3 pins. Now our first pin, the pin which I'm pointing at right now, is called the pole. Alright, now the next pin which I am pointing out is called the normally closed, and the next pin which I am pointing at is called normally open. Alright, so I'm just simply going to illustrate with how you're going to see a relay. Like for example, you're connecting hardware components. How does a relay really look like in an hardware? So I'm going to bring out it right now. Yeah, so we have, this is how the relay usually looks like in a hardware component. Exactly. So when we are making connections, this point here is called a input, where I'm going to connect the input to. So positive of the input and the negative of the input. Then this point is called the pole. Remember I said the pole is where the switching occurs. So the switching point of the pole is connected to this part called the pole. I can see the label in there. Now we have the normally closed. Normally closed is the part that is always closed. The circuit is always complete. And then for the normally open, the circuit is not complete. The circuit is what is broken until when an input signal comes in. So if you have to identify a relay, this is how you identify a relay, a blue cubic component. Alright, so let's move on. Now I've simply explained how the relay works. I've told you the component, what it is made up of. Now I can simply say that the basic construction of the relay, that it is made up of a coil, the armature, the spring, and the contacts. Alright, and the key observation we made was that the input voltage of the source must also match the calibrated relay voltage. I've said that before. Alright, so in setting up the relay, it has 2 basic configurations. Now the 2 basic configurations which I've shown you in the picture below was the normally open, which is what I'm touching now, and the normally closed. Now in the normally open, where my cursor is, the circuit is open and there is no current flow to the load. So when I mean the circuit is open, it simply means the circuit is broken or it is off. Alright, so once a coil, this is a coil, once the coil is energized, alright, the coil is being energized by the input signal, so the contacts close and the input signal makes it to come on. So the normally open will come on when there is an input signal. Alright, now think of it like the normally open is off by default, and then the coil turns it on. And for the normally close, by default it is what it is always complete. The circuit is complete. Alright, and the current flows to the load. Alright, so without the signal it is always on. So we're going to demonstrate it with a simulation. And when an input signal is applied, the coil breaks, right, and the coil simply breaks the circuit, and therefore it turns it off. So I'm going to simply illustrate what I'm saying. It's a very simple simulation. So if I should run this simulation, you can see that once there is no signal, because I've turned off the switch right now, so the switch is off and you can see that there is no signal, but the normally close is lighting up. The LED in the normally close is lighting up. Remember, the LED has to be connected to a resistor because you cannot use 12 volts to power an LED to blow up the LED. So we need to drop the voltage using a resistor. But imagine when I put on the signal, there's an input signal now, the coil becomes energized, and it's immediately, without even wasting time, it switches it to the what, to the normally open. You can see now the 12 volt lamp, which matches the 12 volt battery, is lighting up even without an LED. Remember, you must match the voltage for it to light up, or you drop with a resistor. Okay, so I hope with this sheer explanation of mine I've been able to explain effectively how the relay works.